Are we good? Yeah. We can go? What's up, everybody? How's it going? Good. How y'all doing? I'm Jeremy. This is Brian. I'm sure you all know us by now. You can also call me Schmeichel because IPv6 is the precious. Anyway, we're here to talk about IPv6. We were here last year. We talked a little bit about it. We're just going to kind of give you guys, look back at the good old days, IP version 4, results of the launch day that happened last year, some of the challenges that we're going to be facing in the near future in regards to implementation and stuff we've run into so far, and some of the security and compatibility issues you'll see when you're going from IP version 4 to IP version 6. So to start with, we have a video. Yeah, we're going to have to hold the mic down, so hopefully you guys can hear this. And 10 points to whoever catches the movie reference.
These are just a few of the images that we've recorded. And as you can see, it isn't what we thought. There's been no IPv6 implementation here. No transitioning event. The environment is IP version 4. It's the exhaustion. The IPv4 exhaustion that happened earlier this month. It was supposed to provide internet to the population, bring connectivity to the masses. Well, it worked. The people here got connected, and then it spread to everyone else. IPv4 rapidly spread to the point where we knew we would run out of address space, but we were so short-sighted, we didn't have a plan. There were 4.3 billion IPv4 addresses, and we just let it die. I have to be quick. There was a solution to the IPv4 exhaustion. 4 of them, actually. Brokering, reclamation, software and hardware NAT. Transitioning strategies to get us to IP version 6. For exhaustion, it wouldn't be an issue. I won't have the internet to report this. You have to know, we meant it for the best.
Shameless corporate plug.
Yep.
Integrated broadband services.
Close. Anyway, that was just a video we put together based actually on the talk we did last year in regards to mitigating IP version 4 exhaustion. We can talk a little bit about more of that in a second. But again, my name is Jeremy and Brian. We both work for IBBS. I work in the network engineering group. I've got a CCNP, passed the CCI written, working on prepping for the lab. So we've been tasked with
making the internet work for everybody.
That's right. Transitioning to IP version 6. Brian, you want to say anything specific?
Currently we support about 1.5 million cable modem devices.
Speak into the room. You really need to
put it closer to your mouth.
Yeah. Anyway, right now we support about 1.5 million cable modem devices through our corporation. We also have fiber to the home DSL, and most of the providers we support services to, about 250 service providers. They're smaller MSOs, cable companies, DSL companies, fiber to the home companies. They don't have much budget, much engineering support services of their own, so they come to us to figure their problems out. And one of their big problems is they're out of IP4 space, and they have to figure out a way to get to IP version 6.
So last year when we were here, we talked about some of the solutions that there are to mitigate the exhaustion of IP version 4, whether that's brokering with Aaron and the specified transfer listing service that they have, reclamation of IP version 4 addresses through using private addresses for cable modems, MTAs, so on and so forth, and then hardware and software NAT. So we've had a little bit of experience with these over the past year. Just for some review, IP version 4, deployed in the 80s. Internet Protocol version 6 was brought up in around 1999. You have the differences in the address size, the 32-bit versus 128-bit hexadecimal. The addressing format, it's kind of displayed there. Your prefix notation is a little bit easier in IP version 4 versus IP version 6, and then just the sheer number of addresses.
And even the deploy date on IP version 6, there's been so many changes since 1999 that if you were compliant at that point in time to the RFC, you probably wouldn't be compliant today. So even today, they're still adding and updating the spec.
Yeah, it changes every day. It's actually really interesting if you've watched the way that IP version 6 has evolved over time. One of the biggest things with IP version 4 is network address translation that became very necessary in the 90s due to the pending exhaustion. Everybody knew eventually we were going to be out of address space. So NAT was invented as, kind of a solution to that. Obviously in IP version 6 there's no real need for NAT. So at one point in time there was a form of NAT in IP version 6, but that's been stripped out of the protocol since. So talking more about IP version 4 then. There was, highly limited address space. NAT was seen as the bane of innovation.
Just a Band-Aid.
Yeah, it was just a Band-Aid. I mean, it basically took your public addresses and you shared either a single or multiple public addresses. And that resulted in issues with application layer gateways and several devices that depended on, functionality of having all the ports available on the public address space just broke when it came to using NAT. So over time, there were solutions that were developed around that, but there was still issues. So in IP version 6, they ripped NAT out, and there's plenty of space for everybody.
And NAT is a bad thing when you do NAT and NAT and NAT. So a lot of cases you'll see where you're trying to reserve IP space or control users, like a hotel environment. They may double or triple NAT you before you got to the internet. So that breaks a lot of tools you may use in your computer.
So IP version 4 versus IP version 6. I wish I had the Mortal Kombat theme here, but I don't. Just in regards to the sheer number of addresses, this is just review. Have about 4.3 billion, roughly, if you round up, of which only 3.7 billion are actually publicly addressable. The rest are either private or shared address space defined by the IANA. So on and so forth. IPv6 has a really big number available. Well, actually, 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, 374 quadrillion, and 456. So that is a little bit more. You get to the, if I'm going to point, right here is IP version 4, roughly, and then the rest of the way up is all of IP version 6. So I think somebody calculated there was a IP address for every 3 square feet of the Milky Way galaxy, 1 IP address for every atom on the surface of 100 Earths. So we're doing okay.
There's a couple.
It's better. A little few more.
So you think now.
So we think now. I know the funny thing about that. The funny thing about that is when IP version 4 first came out, the IANA was just like, here, take this, implement it, use it in your network.
Well, it was experimental too.
It was experimental at that point in time. Well, people took it and they implemented it, and oh my gosh, now we're out of space. They're doing the same thing with IP version 6. They're giving out these huge allocations to people saying, here, please take it, use it, implement it. No real regard for what happens if we run out of these huge allocations that you're sending to us. Well, no, the idea in regards to the huge allocations they're giving out now is that you'll never need another one, hopefully. But ARIN recently modified their policies. Instead of just handing out /32s of IP version 6, which was a single address in IP version 4, but is a lot in IP version 6, they're actually allowing you to get smaller allocations and returning some of that address space to pay less per year because people just don't need that much.
And they also, supposedly they're not going to give out more than 15% of the whole address space initially. So they're
supposedly.
That's what they say. So basically, go request your IPv6 addresses. They're going to give you pretty much whatever you ask for, but you will pay for it annually with ARIN. But supposedly they're only going to give out the first 15% and then start locking it down a little bit.
Supposedly, until the spec is revised, as they say. So the image you see at the bottom of your screen here, ARIN IP version space 4 available. There's 2.48/8s remaining.
Basically, we're out.
Pretty much out. I mean, the global registry is completely out.
And this is the bad space. I mean, this is like the Bogond area, the blacklist space they got back. even if you got an address block in this, there's a good chance you won't get to half the internet because these are really bad addresses.
Well, Aaron has said as depletion occurs, as the address space starts to run out, they're going to start to run into that nasty address space that's just really the dirty bottom of the barrel stuff, and they won't have time to scrub it completely because people are so hungry for the address space again that they're just having to kind of look at it and say, well, I think we cleaned it up and here, have it.
Yeah, the demand's exceeding the supply.
So it's good stuff. So here's a beautiful chart showing about where we're at right now. The interesting line here is if you can look at the blue line, this is the Asian Pacific allocations. It's like all of a sudden they went out.
Do that again?
Actually, the funny thing about it is I had written down here a wonderful reference to There Will Be Blood. They actually approved interregional transfers, so the Asia Pacific folks can drink Aaron's milkshake. They can drink it up. So this little purple line here, this is Aaron going down steadily, steadily, steadily. I expect before the end of the year for sure, Aaron will be completely exhausted.
And there's talks of some organizations in Asia or even in the U.S. possibly buying companies in South America to get address space. So they can go ahead and start locking in address space and work on transfers. So technically it's regional. You're supposed to keep the address blocks within the region, but now it's gotten so low where they're allowing some exceptions to the rule. And larger companies are actually going and looking to find cheaper solutions to get address space because the cost of an address is anywhere from $5 to $14 right now. And it's not going to go down. It's just going to keep going up.
That's ridiculous. I actually, because sorry.
Stop directly behind the speaker. No, just keep it where you're at.
How about there? Is that better? All right, we're good. What I was going to say is I was actually talking, because we work in the cable industry, we have a lot of experience working with different providers, talking with them about whether they get address space from their direct service provider, because even cable providers have to get an internet circuit from somewhere, whether that's AT&T or Comcast in this case. Comcast is getting ready to charge this guy $400 a month for a /24's worth of IP address space.
Just the address is not bandwidth.
Per month. So, I mean, you can go out to Aaron and get I think it's a /22 for like $1,500 annually. So, but the problem is Aaron's about out. So, what are these smaller service providers going to do when it runs out? Well, and then we get back into the whole mitigating IPv4 exhaustion.
Brokering black market IP addresses.
So, but the companies are looking at acquiring other companies. They're actually viewing the IP address resources that companies have as an asset, and it's actually a measurable asset now due to the depletion. So, last year IPv6 was launched.
It's climbing high, but
yeah.
It's really not past 1.3%.
So this is Google's graph, full disclosure here. This is actually the traffic, all native IPv6 traffic that's gone through Google. Gets up to about 1.3% as of yesterday when I pulled the graph, or a couple days ago, I guess. But still, it's not a lot. Not a lot of native IPv6 traffic yet. So even though it's out there, it's in the wild, it's been deployed, there's still not a lot of people using IPv6. Well, what's going on with that? There's still consumer challenges to a certain extent. Windows XP last year had like 35% penetration still. It's down to about 17.6. Windows 7, 8, the kingpins for sure. Not 8 so much as 7. But the problem is, most people aren't connecting their individual machines directly to their internet connection. Usually have a router or something like that at home, right? So people don't usually replace their routers unless they break. So you probably have a 5 to 6 year old router sitting in your house, for most folks anyway, that there's no chance it'll do IPv6, at least with the way the spec exists today. So the interesting thing that we've seen in our labs is even different consumer routers implement the spec differently. We'll talk a little bit about that more in a bit, but I don't know if anybody heard about the debacle. Well, we'll talk about that in a second, but remember the Cisco Linksys debacle? I think it was last summer, where they did a forced cloud update on all the consumer devices, and basically, he threw me for a loop. Did a forced update on the consumer devices and said, hey, you guys got to register for our cloud service if you want to use your internet connection. Well, you can about imagine exactly how well all the consumers took to being told what they have to do. So that was a big issue for Linksys, but you have to understand what they were trying to do is, from my perspective, anyway, I understand what they were trying to get at. They were trying to make it so that all of the Linksys routers are fully capable and updated to the latest firmware so they can accept v6 addresses and read all of your data. But no, I'm just kidding.
They probably had good intentions. They went about it the wrong way.
Yeah. So, I mean, that was a lesson learned hard, and now Cisco is actually selling Linksys to Belkin, so it doesn't matter anyway. But Comcast, actually, there was a news article this week. They've fully deployed IPv6 on all of their ARIS infrastructure. I'm not exactly sure, since I don't work for Comcast, how that compares to their Cisco infrastructure, but, you know.
Probably 50-50.
Roughly. But that is a milestone. I mean, there's been some growing pains. Again, we're getting into the consumer router differences here. We have a lab at the company we work for. We've got a Cisco 7246 VXR. IPv6 is aliens, yes, by the way. And we've got, you know, cable bundle on there that's configured with all the necessary commands to make DHCP v6 work, because in the cable world, you have to use DHCP in order to track your customers, so that way if you get a CLIA or subpoena request, well, subpoena's not a big deal, but CLIA, yeah, that one you got to worry about.
And some of the other things too is you just need to control out the allocations as you issue them out. So you're using the same platform, so you really need to keep the same basic theory going instead of just throwing statics out there. You need to stick with GCP, and one of the first things you run into is DHCP v6 is just really only supported on very few operating systems. You got to be, if you're on the Mac, you got to be at least Snowline to even see it. And then on Windows 7 and 8.
Mm-hmm. What?
Snowline?
Or Snow Leopard, whatever it was. Mountain Lion. It's some
Snowline
kind of,
is Macintosh's new operating system that they haven't released yet, but we just, no, I'm just kidding. But anyway, it was interesting because we have 3 different router vendors in our lab right now. We need to get a Netgear and a Belkin, but we don't have it yet. But we've got ASUS, D-Link, and a Linksys. The Linksys router, we were working on it, and it would accept an IPv6 address, but it wouldn't hand anything to the devices behind it unless you put it in bridged mode, which was really strange. And then the ASUS just didn't want to play nice until we did a firmware update. The D-Link won't accept an individual IP address. It has to get a /64 allocation so it can hand out addresses to devices behind it.
Yeah, it's very greedy.
So it's really goofy because every vendor has a different implementation. So as we move forward, hopefully, you know, a firmer standard will be developed. But for now, there definitely are a lot of differences in the consumer routers available to people that go to Walmart and buy a router today.
And our idea with our testing is to basically match up what a consumer can purchase. Because you know, when you're dealing with an ISP, unless they're giving you the equipment, you're probably going to want to use whatever you have. So we're trying to figure out what they can go pick up at Best Buy or Walmart and how compatible it really is, so we can kind of gold certify devices we know work, and then say you can use what you want, but we can support these devices. And we're trying to get ahead of the ball game.
Well, trying to. The complexity in regards to the configuration. So it was interesting, he brought up static addressing earlier. Who's going to type a static IPv6 address into their device?
You'll probably do it once. You'll do it once, but you probably don't want to do it again.
Does everybody know how to copy and paste? It's a very useful skill when it comes to IPv6. One of the other...
Truncation.
Say what?
So is truncation.
That's right, truncation. Abbreviate. We're actually going to get into that in a little bit. But talking about some of the carrier grade NAT issues too, so like he was saying, when you have NAT on top of NAT on top of NAT on top of, well, NAT, you run into some problems. Things break. Not everything works as intended because it wasn't designed to function like that. So, you know, your video streaming, your Skype calls, your...
When their Netflix and their Xbox don't work, they call and they are very upset. So
yeah.
You got to make sure whatever you implement to keep them up on the internet is compatible with their current devices. And a lot of the devices in the house won't be IPv6 compatible, so you have to have some kind of edge device.
And if I can't get online and play with my pandas in the World of Warcraft. Edge access, that's right. But IPv6 has IPsec built in, doesn't it? Yeah, oh yeah. It does. It does make end-to-end encryption a lot easier in IPv6, but it's not backwards compatible. It introduces a whole host of new problems when you're trying to implement a brand new protocol on your network. This is actually one of my favorite slides. The link local address in regards to how actually hosts communicate on a network. So what we've seen in our lab testing is when a host comes online, it assigns itself its own link local address, which is like the 169.254 addresses in IP version 4, but it actually has a use in IP version 6. It's the whole let's see, FE80 followed by 54 bits of zeros. The last 64 bits is the 48-bit MAC address with FFFE stuck in the middle. So if you know, if you're on a network and you know link local addresses, every link local address has that device's MAC address in it, well...
With FFEE in the middle.
Well, you can just strip that right out and, hey, look, I've got a whole MAC address table. That's a little bit of a security flaw. Unfortunately, all hosts, when they come online, especially if they're using DHCPv6 or Slack, stateless auto configuration, they'll use their link local address to talk to their local router and say, hey, I need an IP address. Hey, what's the address of this neighbor that I need to get to, so on and so forth. So there's a lot more traffic on an IPv6 network that you have to be mindful of in regards to what we had in IP version 4. Let's talk about intrusion detection, intrusion prevention systems. If they don't understand the traffic, they're going to drop it. Well, IPv4 isn't compatible with IP version 6. IP version 6 isn't backwards compatible with version 4. So you have to have network devices that understand both and are capable of filtering both.
Yeah, I mean, they got to run dual stack, and they actually have to be able to correctly interpret all the standards within IP version 6 and any of the security potential risks you have there. And that's going to be a very interesting landscape as we move forward. So if you have an exploit, it may not work in v4 because it's locked down and the security systems in place can block that. But with IPv6, every device in the network's public. It's connected to the internet, so it's out there. So how do you protect all those?
Yeah, it's actually pretty interesting. There was an attack that I read about this week while I was prepping for this talk in regards to packet amplification. So the router header in IP version 6 is a simplified version of the v4 header. What you can do is actually you can place a 0 in the routing header of each packet. It causes them to travel in a looped path. So the ping pong exploits take advantage of the wealth of /64 subnets available in the protocol. That's what every router is going to get in your system, is they're going to get a /64 so they can delegate addresses to the devices behind them. So it basically allows attackers to send packets from one non-existent connection to the other. Thus, you're not undDDoSable. Sorry. But
it's kind of like an ARP attack on a layer 3 platform with v6.
It basically results in an endless series of ICMP unreachable messages. So networks are just flooded with garbage data. There has been an RFC that's been proposed to depreciate the router heading of 0. Hopefully that will go through soon because this is one of the biggest known IPv6 exploits at this time. So you have your issues with your security information and event management systems. No, there's no current security information event management system that fully supports IP version 6 yet. So you're not going to be able to ID multiple addresses by the same host because everybody that has a link local address will also have a global IP version 6 address. There's no efficient way to track that yet. So.
And sometimes they're running dual stack and they're running both protocols at the same time.
Yep. So talking about the issues with grep and your logging servers, there's different ways to display IP version 6 addresses. We were talking about truncating the addresses earlier. So you have your first method where you don't drop the leading zeros, and you have your second method where you forget to use a double colon, or you just have the actual RFC 5952 standard. Your logging systems all may use different logging methods. So you have multiple different IP version 6 addresses throughout your different logging systems. There needs to be a standard, basically, is what it comes down to. If you don't have a standard, then you're just going to be like, well, I'm going to grep this style address. Well, half your logging systems might have it. The other 2/3 might have, well, other half might have this one, and then you just may not use RFC 5952 anywhere. So it's important to understand the standards and try to reconfigure your logging and system information event management systems accordingly.
You kind of need to pick one way to display your addresses and stick with it. Because if you script anything to track stuff or monitor anything, you really need to stick to one format or you're going to break your stuff.
And again, this is a result of the evolving IP version 6 spec. So the one on the bottom, that's the best one. That's the RFC. That's what you should try to stick to if you can. Other issues, no reputation-based protection. This gets back into the whole issues with the current IPv4 spec and handing out the junk space right now. There is currently, for IP version 4, reputation-based protection. There are known malware hosts, known sources of botnets, so on and so forth, that are just like, nope, denied, sorbs, blacklist, so on and so forth.
bogon space.
Right. Well, it's like a chicken and egg thing, which is the same issue we've had with the content in regards to IP version 6. What comes first, the host or the content? Well, you know, it's the same thing here. You have a bit of a chicken-egg situation in regards to reputation-based protection. Nobody has established an IPv6 reputation database, so no one's using a reputation-based security database with IPv6 address, and therefore no one is building a reputation database. It's looping logic. You're basically screwed until somebody takes action.
And even once they do build it, I mean, you have such a large range of addresses from Aaron, you just start spamming off a new address. You just move down your block to another area, and it'd be difficult to block the whole subnet, because then you're blocking a huge chunk of address space, which, if it's a service provider, that could be thousands, millions of customers. So how you manage a blacklist will also change dramatically.
So that talk ties right into the next point. Effective rate limiting is almost impossible in IP version 6. Due to the sheer size of the spec, it's just impractical, especially since most current standards deal out /64 subnets to edge routers. So for some perspective anyway, a /96 in IP version 6 is roughly equivalent to the entire IP version 4 internet. There are 4,294,967,296 /96s in a single /64.
Yeah.
So that many IP version 4 internets exist in one /64, which is what we're handing out to customers, saying, here, have all this address space. So the customer can just be like, well, I'm wanting to do an attack on this site. Oh, that IP got blocked. Let me just switch to one of the other millions and millions and millions of addresses I have and just slide right through it. So what will we do? What will we do? Build solid transition plans. I mean, the same can be said. It's just networking 101, right? You've got to make sure that you're aware of what you're doing, what network elements it's going to impact, and implement one thing at a time. So,
I mean, you also got to understand that you're going to be running dual stack probably another decade. So even if you get IP6 up and running in your network, your core is the easiest place to get it going. It's out to the individual endpoints where you're going to have problems, but at the end of the day, you're still going to be running a dual stack. You're going to be running both address spaces, so you have to be able to manage that migration of when do you eventually finally drop the v4 space.
And that probably won't be, like you said, for at least another decade. IPv4 may never go away. We may be dual stacked forever. Just depends. It's hard to say at this point. Auditing your IP version 4 network, that's definitely something that's really important. You got to clean up, throw out, upgrade. Clean up and kick out outmodeled or outdated features. The audit consists of ensuring every aspect of your network that can be effectively upgraded to the next level, especially firewalls, intrusion detection, intrusion prevention. Start with a clean, uncluttered slate. It makes it much easier to implement IP version 6. Again, you want to do the gradual implementation. Update, implement IP version 6 compatible network elements individually, so that way you can monitor anything that changes, any sort of negative impact on your network. You can just roll that back real easy, see what went wrong, try again. Usual suspects such as VPN tunnels, malicious traffic, requiring authentication everywhere, so on and so forth. The syntax, that was an interesting, actually, thing I wanted to go over. The syntax it's pretty similar to IP version 4, right? It's just hexadecimal. So at the base of it all, it's pretty much the same. You just got letters in your numbers. But knowing the syntax makes it much easier to quickly deal with a security breach or implement necessary countermeasures. Since it's already been around for more than a decade, there's no shortage on information on IP version 6. There's a wonderful 188-page guide from the National Institute of Standards and Technology, aka the U.S. government, if you want some light reading. So. And
just keep in mind, when you do find and research information on IPv6 for deployments or moving forward, check the data documentation. If it's pretty old, there may be RFCs that have been updated and upgraded since then. You don't want to get on an upgrade path of something that isn't going to work. And then you also have to verify how much support the equipment you're trying to deploy it on really has. And just try to run with the latest firmwares, microcodes, iOSs, FPGA images, whatever you need. But make sure you're running the latest code that's supported in v6, so you're not already behind the power curve before you start.
And in regards to the big red button, I'm a big believer in big red buttons. It's a kill switch. IPv6 attack, If you still have IP version 4 space, have a very easy either scripted method or at least scripts available to you in order to quickly revert to IP version 4 and reroute your traffic out that area.
If you're getting attacked on V6 space and you can still run dual stack or V4 space, you might just want to turn the V6 off for a while.
Yep, because obviously by this point, I hope you know what you're doing in regards to IP version 4, because if you don't, God help you. So the too long, didn't read version. IPv4 here to stay for a while, at least another decade. IPv6 is picking up steam slowly. Upgrade, 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 dual stack, and it will be okay. You really will.
Start making your budgets like yesterday, because the quicker you get in front of this, the better off you're going to be. And the more experience you have, and the more marketable you'll be also. It's not going away. There's no more V4 space left. So jump on it as soon as you can.
That's it.
Thank you.
Thanks, guys.